Ing. He's so good at teaching. I love math.
What?
Alright, so how do you test if something is a function? Well, we do something called the vertical line test, VLT. If it passes the vertical line test, then yes, it is a function. If it's a function, then we can ask this next question. Can I take the inverse of that function? Well, the test, if I can take the inverse of that function, we use the horizontal line test, HLT. If it passes the horizontal line test, then you can take the inverse. When you take the inverse, it basically means it's 1, 2, 1. But if it's not a function, it fails the vertical line test, then you cannot go on to take the inverse. It just stops right there. It's not a function. Now, sometimes it can be a function, and then it fails the horizontal line test, and it's not. You can't take the inverse. Let me give you a couple examples of these. Alright, so let's look at this one. Let's see if it passes the vertical line test. Class, right here, does it pass or fail? Here? So is it a function? It's a function. Let's do the horizontal line test now. Pass or fail? Why does it fail?
Because there's 2 points at it.
Yeah, it goes to the 2 points here, so it is a function, but you cannot take the inverse. Let's try this one. Class, is this a function?
Yeah. Yes.
Horizontal line test. Pass or fail?
Yeah.
Right, it's touching there multiple times. So, although it is a function, I cannot take the inverse. Pass or fail?
Yeah.
Class, should I ask the question
No.
the inverse? No, right? It just stops right there. Let's do one more example. Let's fit it down here. Can I fit it? Let's try to fit it here. Class, is this a function?
Yes.
Function. How about horizontal line test?
Yes.
Passes, right? So this is an example of a function in which we can actually take the inverse of.
Hey guys, let's go over C1. Determine whether each function, so we already know it's a function, it's passed the vertical line test, is invertible. Invertible is another word just for inverse. And we're going to use the horizontal line test. For C1, I'm just going to place a line anywhere you want. And if you go through multiple points, putting red dots, there's 2 there, so that's bad. 2 is bad. So this is no. This function is not invertible because it fails the vertical line test. So Just cross off those parts. C2. Determine whether each function is invertible. Use the horizontal line test. If I put a horizontal line, it has one dot, it passes. If I put more than two dots, then it fails. Let's go ahead and just randomly put horizontal, or you can actually put your pencil down. And I do want to note that at this point right here, it actually passes. But it has to pass at every location, and this part it fails. So no, this is not invertible because it fails the vertical line test. You can't take the inverse. Alright, in C3 we need to check if this function has an inverse. Remember, we're going to use a horizontal line test. If it has one dot, it passes. If it does two dots, it fails. It's not invertible. So in C3, I have this function here. And if you're confused, you can always just do a bunch of them. Okay, I'm going to try to do the one that I think most students get stuck on right there. Okay, so we know that at each of these points, there's just one that passes, where it intersects the graph, passes, passes, passes. Okay, now this one looks like it's a bunch of dots, but the answer is that it's just going through once. The reason why is I can't zoom in any closer, but it basically gets super close, but the yellow does not on top of the black line. It only intersects at one point. So let's go ahead and fill this out. Yes, oops, probably too thick. Yes, this function is invertible because it passes the vertical line test. That was C3. Alright, C4, we have to look at this function and see if we can take the inverse. To use the horizontal line test, you can put your pen or pencil down on the screen or on top of the graph and see how many times that it intersects. If you see one dot, it passes, but if you have two dots, it fails. You can put them anywhere you want. These are horizontal lines. Okay, down here, this one passes because it's only going through one point. That's actually the vertex. But at these other locations, they fail. So, no, this is not invertible because it fails the horizontal line test. C5, let's see if we can take the inverse of this function. And to review, we're going to put some horizontal lines. One dot means pass, two dot means it fails. Let's take a look at this one. This looks like a negative cubic root. Go ahead and put a bunch of horizontal lines wherever you want. Okay, here. It's going to pass, passes, and passes. Okay, on this one, it looks like that the yellow is on top of the black, and the reason why it actually passes is because this point right here, you might have something like, I'm already zoomed in all the way, negative 1.02, negative 1.01, and what's happening is the number is approaching 0. 0.24, 0.23. But what will happen is the number will never be, the numbers for the y values will never be the same number as 0. It's just the only time it's gonna be 0 is at the order pair 0, 0. So, yes, this is invertible because it passes the horizontal line test. Scratching this off because that completes our sentence. So that's C5. Alright. For C6, determine whether each function is invertible. We already know it's a function, it's already passed the vertical line test, now we're going to see if it has an inverse. To do that, we're going to use a horizontal line test. If you put a horizontal line or a line that goes left to right, if it intersects the graph once, that means it passes there in green. If there's more than 2 dots, then it fails, it's not invertible or doesn't have the inverse. Alright, this looks like an odd degree function. I know that because I see the arrows going in opposite directions. I'm going to lay down a couple of horizontal lines to the best of my ability here. Okay, it's going to pass here, 1 dot, passes here, 1 dot, passes here, 1 dot. And here, although it looks like the horizontal line intersects the graph at multiple places, it's actually only going to be 1. So the answer is it passes. And here is my explanation why. If you drew yourself a table of values, and if you did something like here on the positive side, let's just say x is 0.1, you might have something like 1.11. And what I'm trying to show you here is that it's slowly increasing there, and you will not have a y value that repeats on the y's. Okay, so that's the answer for C6. So for number 6, to finish up that problem, yes, this is invertible because it passes the vertical line test. Scratch off these other parts of my sentence frame. So yes, this function is invertible because it passes the horizontal line test.
It started out with graphing and then it went to functions. I'm doing FOIL to solve x. Next is the expressions. Now I have to see if x is equal to or greater than 3. Now you make that point on the x-axis. Wait, was it a positive 3 or a negative 3?